This is the On All Cylinders podcast,
powered by Summit Racing.
Your host for today is Summit Racing's Paul Sokolis, with special guest, automotive journalist, writer, and builder, Jeff Smith.
Here we go.
Hello and welcome to another installment of the On All Cylinders podcast. I am your host for today, Paul Sokolis. And in 1980s television sitcom parlance, we've got a very special episode for you today. And that's because we're bringing in friend and On All Cylinders contributor Jeff Smith. You see, it's the 55th anniversary of Summit Racing Equipment this year, and we thought it'd be a really cool idea to kind of talk about the evolution of the gearhead hobby, the home hot rodder, from the company's inception in the late 1960s to today. You know, we'll talk about how it evolved over the decades and even take a glimpse towards the future as we become increasingly electrified nowadays. But before we get to explaining exactly why Jeff is the perfect person to talk to about this topic, Jeff, welcome to the show. Thanks for being here.
It's a pleasure to be here. Yeah, this is going to be a lot of fun.
I do too. I think this is going to be a really interesting kind of retrospective and kind of crystal ball prediction session here. Before we get to that, though, can you give folks a bit of a background on how you got into all this?
I grew up in Iowa and was reading the car magazines. I worked for my grandfather in the gas station starting when I was 10 years old, and would, just devour Hot Rod and Carcraft magazine. And I told him one time, Papa, this would be the world's best job. And he laughed, and he never tried to dissuade me, but never really encouraged me either. And because that was such a pipe dream. And that literally started somewhere around probably when I was 12 or 14. Went to Iowa State University, got a degree in journalism, and decided to take my shot at the car magazines, and moved to California in 79 and convinced Rick Vogelin, who was then the editor of Carcraft, to hire me. And that started my career at Peterson Publishing. I was the editor at eventually became the editor at Carcraft, and then eventually went to Hot Rod in 87, was the editor of Hot Rod from 87 to 93. And then eventually there was a change in editorship at Chevy High Performance Magazine, and an old publisher, a friend of mine, Jim Adolph, was the publisher, and he let me have another shot at being editor. Then we did that for Chevy High for a number of years. We're very successful. And then eventually they asked me to come back to Carcraft as the editor for a couple of years. And then Peterson then was sold. There was a whole series of different owners in less than 10 years. It was crazy. And started doing a tech column for you guys, among writing for a bunch of other people. And that's been a lot of fun. I have friends who constantly have questions. So there's never a lack of material. So I've been doing this for, now over 40 years. That sounds terrible. Oh, my God, 40 years. I was 10 when I started, by the way.
Now, when you got into this at 10 years old, do you remember what kind of cars you were working on? Was there any specific make model that really sticks in your mind?
No, not really. If I had to pick something, because there's one car sticks out for just terrible reasons, but a 59 6-cylinder Chevy Impala. I had to change the oil in it. And in the old days, you had this, it was a pedestal with a bucket on it, right? And you drained the oil in this bucket, and then you'd lower the pedestal down. It had a slip on it, and just a lock cylinder. You'd slide it down and then drag it off the side you were standing under a car hoist. And I was probably, 12 years old, and grabbed this oil drain after I drained the oil filter out of it, and went to slide it over, and I hadn't lowered it down. So the center of gravity was extremely high, and pitched it right on myself and dumped about 5 quarts of oil all over the front of me. I was probably 12 years old.
You laugh, but you're still here doing it.
I'm still doing it. And it's, I get the question oftentimes. People say, do you love working on cars? No, I really don't. That's most of the time. It's frustrating. It's difficult. You chew up your hands and stuff. But I learned very early that I couldn't afford to pay somebody else to do the work for me. So I had to learn how to do it myself. And there are certain things I'll do and a lot of other things I won't, So I've educated the people in town that I'm not a repair guy. But don't call me with your Honda questions, because I have no clue how your Honda works.
That is a fair assessment of the gearhead hobby. I mean, when it's great, it is great. But then there's also the days where it's, 28 degrees in your shop, you're on your back trying to unstuck a bolt that hasn't budged since the Cold War, and then it's not so great, right?
Oh boy. And had my share of, we could talk for hours about this most recent episode with a small block Chevy, but I won't bore you with it. But it turned out that the camshaft, I had this crate engine, and this led to an engine that I built for Summit, a budget engine that I built for Summit that we did some testing on.
You talking about that 355?
The 355, yeah, where I had this crate engine, never ran right. And I finally pulled it out of the car, been in the car for like 8 years, and discovered that the camshaft was not aligned with the main journals. It's actually skewed. And so the engine was running as 8 individual single cylinder engines. And that's why it never ran right. And it took years to figure this out. I've got the motor out of the car, I've got the block disassembled. We're going to take it outside and take a sledgehammer to it. So no one else is tempted to use it because it's cursed. It's absolutely cursed. And then I told my friend of mine I was going to bury it in the backyard. He goes, "Oh, don't do that. It's cursed. Bury it in somebody else's backyard."
But isn't that the enduring legacy of the small block Chevy anyway? I mean, it'll run longer poorly than most engines run at all.
This thing, but it never ran right. I had half a dozen. So when, for example, we'll probably get into this in this discussion, but people oftentimes will blame the carburetor or blame the distributor or blame fuel injection or blame whatever. And I did all of that. I was looking for the source of this problem. And over a period of 14 years, it took to finally find the problem. Oh my God. And in the meantime, I had half a dozen induction systems on this engine, 4 different camshafts, 5 different carburetors, 3 different fuel injection systems. It was ridiculous, and it never ran right. And now I know why. It took 14 years to figure it out, but yeah.
But you finally figured it out, right? And I think that speaks a lot to the tenacity of everyone in our hobby. You want to keep working through a problem until it's solved, no matter what, even if it, takes a handful of decades. But you kind of touched on it earlier. The genesis of this interview is in conjunction with Summit Racing's 55th anniversary. We kind of wanted to take a look back at how the hot rodding community, how the automotive aftermarket industry has evolved in the past few decades, starting, say, in the late 60s and moving on to today. Can you kind of contrast the way Gearheads worked on their rides back then compared to what it looks like today?
Well, compared to today, ridiculously crude. I mean, from the standpoint that by the early 80s, at least people were accepting electronic ignition. I mean, that's just that seems now almost dated. Like an HEI distributor was still pretty high tech. I can remember helping some drag race buddies, friends of mine that had a drag race car in the mid 70s. And we had one of the first XL breakerless ignition systems, BEIs, and had all kinds of problems with the engine and the ignition retarding. Classic example again, blamed the ignition, blamed the new technology because it's a black box, right? Don't know how to deal with it. And turned out we had not put a button on the roller camshaft because we didn't know. And so when you rev the engine up, the timing would retard like crazy. We'd lose 25 degrees. And so we'd have to run the engine at 55, 60 degrees to get it to be anywhere close to 40 when the RPM came up. Never did figure that one out until much, much later. So, the technology was a little bit better, but not much. I mean, electronics were brand new, brand new. So yeah, in a lot of ways, we're still carburetors and a lot of people were still running point ignition systems, quite frankly, which is pretty crude. And yet, motors still made really good power. So electronics were just starting to turn the corner. Carburetors weren't really nearly as sophisticated as they are today. Manifolding, not nearly as good. People just crude tools, I guess, would be the best way to put it. We're far more sophisticated now. Even with something as simple as a carburetor, there are far more systems now that you can apply to make these much more efficient.
Now, was there a single product or single innovation that, when it hit your desk, you had to take a step back and say, whoa, this changes everything?
Yeah, that would have been, I did a story with a guy named John Meany, who is still building fuel injection systems today. He was a young engineer. He'd met my good friend John Lingenfelder and had built a basic electronic fuel injection system. His was not the first. Bosch had done it much, much earlier. But they were crude starts. And he had a basic electronic fuel injection system I did a story on in Hot Rod, I think in 88. I think we called it smart squirters, if I recall the title. And that was an introduction to the first real basic electronic fuel injection system, which was only dealt with the fuel side, did not deal with ignitions at all. That came later, and which eventually became the XL fuel injection system, and eventually became DFI, digital fuel injection. That's probably the greatest change, I guess, that I've seen, because what it's really about, if you step, that's like a grove of trees, perhaps in the forest. To step back and look at the entire forest, it's really about control. And if you look at all the things that have happened subsequently to that, the technology that's been applied to automobiles in general, it's all about control. And now everything has gone from, if you want to use an analogy, a set of points is a mechanical control for the ignition. You physically turn the distributor, set the timing, and the points open and close. It's all mechanically driven, and then you've got a mechanical advanced system. It's, as a friend described it to me, it's like a whirligig on the top of your distributor, because it's a centrifugal mechanical device. And then another vacuum advanced canister, which is also a mechanical device. Those combined to set the ignition curve. Now we can change it in tenths of a degree per RPM if you want to, and individual cylinders, which took a lot of machine work to do that. Like NASCAR guys were doing it for years by modifying their distributors, essentially the point plate or where it triggered the ignition. They would physically move it by machining it. And now you can do it electronically with a keystroke.
Now, when these EFI systems showed up, were they quickly and readily adopted, or were there still a lot of folks going, I don't know, I'm going to stick with my carburetor because that's what I know?
It was the latter, very much the latter. And we knew that going in. We knew that we were just introducing the technology, but it wasn't going to be universally accepted. In fact, I can remember it might have been that story or one of the subsequent electronic fuel injection stories that I wrote probably in the late 80s that said, flat stated, the carburetor is dead. which is why you should never ask me to prognosticate, to look at my future thing, because I'm also the same guy that said, yeah, that Chrysler, that concept car that they built, that Viper thing, they'll never build it. They'll never build that. It's cool. It's very cool. It's cool as hell. They'll never build it. So, but looking back, which of course, your vision is very, very clear there. No, it was not accepted at all. And we even did comparisons on carburation versus fuel injection system, and too much to the glee of the carburetor guys. Usually carburetors would win on a very slight advantage because you're essentially just introducing the fuel further upstream, and the further upstream you introduce the fuel, the more power you're going to make, because the fuel tends to cool the inlet air temperature. So that's the only reason. But the rest of the time, because you're so much more accurate cylinder to cylinder, you can end up making more power with fuel injection systems, So, but no, it was not universally accepted. It was universally canned. No, nobody was interested. And then it just took a long time. And part of the problem was it required, and you have to remember, now we're just one step above what a TRS-80, Radio Shack computer, right? Yeah, I mean, an MS-DOS. How about that? We're one step above that. So laptops were very, very high tech, very expensive. Very few people had them. And you needed a laptop or a computer in order to tune these things. And so I can remember literally parking my car in my garage in my house in California and then running a cable in through the garage door into the den where my computer was, so I could work on a computer on my car because I didn't have a laptop. So it was very crude. And it took a long time. And so it was only after laptops got inexpensive and easy to access and the systems became less complex. The early systems, looking back at it now, they were pretty crude. And like I said, they even controlled only just to control fuel. It wasn't until much later that they controlled the ignition. It was electronic control, if you want to use that generic term, because now you got electronic control for boost on turbochargers and all kinds of things.
And not to mention electronic transmission control.
Transmissions, yes. I get questions all the time. I'm thinking of putting a 700R4 in my Chevelle. And it's like, well, you might want to consider a 4L60E instead. It's the same transmission. It's just that now you've got much more control over the shift points, whereas you have to go back into that governor and change the weights and springs and deal with that whirligig in there. Whereas electronically, you can say, I want this thing to shift at 6,125 RPM. And that's where it shifts, and it takes 2 seconds to do that with a keystroke. That's the advantage of it.
Yeah, I guess nowadays it's just kind of a no-brainer. Like, why wouldn't you want to just press some buttons on a keyboard as opposed to fiddling with weights and kickdowns and, adjusting things in a transmission valve body, right?
Oh my goodness, yeah, and balancing between the governor weights and springs on a governor, because a 700 R4 still uses the same governor basically as a turbo 350. Balancing that with the small passages and stuff in the valve body, because they're not mutually exclusive; they work together. Oh, it takes hours and hours and hours. I've done it, and it's a pain because you go out, drive the car, come back, jack it up, or put it on your hoist, and then take the governor cover off, pull it out, change the weights and springs, put it back in, go out and test it. And you don't really know what combination of weights and springs you need until you've tried it a few times. Yeah, it just saves so much time. That's the big thing.
Now, you're on the front lines here. You said yourself you get a ton of questions from folks working on their cars. Are you seeing the mix of questions you're getting kind of even out? Or is there a bias to like old school carb tuning or modern EFI programming? What type of questions are you getting nowadays?
It's funny. You guys give me a little report, usually maybe once a year or so, on the best responses to the highest responses to the questions, right? And the biggest one has been on an inline Chevy 6-cylinder, a 230 Chevy 6, which I was shocked by. I did it just because it was fun. It was a great question, and I didn't know anything about it, so I looked into it, and it just generated this tremendous response. So there's still an awful lot of old school guys that still want to talk about those things, and that's fine. There's nothing wrong with that. And then the biggest thing I think with the electronic stuff that I see where people blame it is and I've been there. I've done this. I'll give you an example. Put a DFI system on my race car, my Chevelle, my road race car, and went to fire it up. Was going to drive it out the driveway and load it up on the trailer. It got about halfway down the driveway and quit. Just shut off. Wouldn't start. Crank over just fine. I had the engine cranked over. I had power. I had fuel. I had no spark. So I called John Meany and said, did the computer fail? And he goes, no. If you have fuel, there's something else that's wrong. You're blaming the computer for something else wrong with your car. And I said, well, what do you think it is? He goes, I don't know. Fix it. And quit pestering me. He hangs up on me. So, which is classic John Meany. So I spent like half a day thinking about it and trying different things. Turned out that the tack lead over to the coil to run my tack had grounded out, and that had immediately killed the ignition system. So it had nothing to do with the fuel injection, but yet instantly you would blame the fuel injection. So, and in the case of my El Camino, that engine I was talking about that ran so poorly, blamed any number of different fuel injection systems for it. In the back of my mind, I'm thinking, I've changed fuel injection systems. I've gone back to carburetors. It still runs poorly. So it wasn't the fault of the fuel injection at all. It was a mechanical issue. And so there's where it's become much more difficult to diagnose the problem, because you've got different levels that you have to work with. And so whenever we got on the subject, I always like to tell people and say, and I don't follow my own advice all the time. Do the simple stuff first. Has it got gas in it? I'll give you an example of this. I won't use his name because I don't want to embarrass him, but we spent probably 5 hours on the phone, half a dozen, 10 phone calls over a period of like the last 4 days, with fuel dripping out of his pair of carburetors into this 409. And we went through all these different things it could be, and blah, blah, blah. And he checked it all out. There's nothing, blah, and the shortcut version of the very long answer was he had inadvertently dumped 3 gallons of kerosene into the engine, into the gas tank rather than gasoline. And it just caused all kinds of problems that were extremely difficult to diagnose. And I said, you didn't smell it when you dumped it in there? He goes, I wasn't paying attention. He said, but it did smell funny when we were listening, but I just figured it was bad gas. So we finally drained it out. And then I realized what I had done, because I had 2 gas cans. One had gasoline and the other one had kerosene. Went to use the kerosene and I'm like, uh-oh. So you just never know, and blaming the carburetors, blaming the ignition system, blaming all this other stuff. And I kept telling them, I don't know what the answer is, but when we figure it out, it'll be something simple. And it was.
Okay, so what about you? Forget the hypotheticals. What would you prefer to do? Would you rather pound a keyboard or turn screws on a Quadrajet?
At this point, I'm comfortable with both of them. I would not try and steer somebody one way or the other. I had a situation where a friend of mine was restoring had taken this customer's car in, had fuel injection on it, and he's a carburetor guy, didn't know anything about it. Came back and the thing ran really crappy, and we discovered that it had a bad O2 sensor in it. Actually, it had two things. It had a bad throttle position sensor, and it had a bad O2 sensor, both of them. And this was a brand new fuel injection system. I don't remember whose it was. It doesn't really matter. It happens, if production parts are going to, and it had two problems with it. It took us a couple of hours to figure all that stuff out and change it. But I've had just as many head scratching moments with carburetors. So, it's just one of the things, and things are constantly changing. Ran into a situation a while back where the little O-ring on the needle and seat on one of my Holley carburetors just dried up and broke and flooded the carburetor over. And I thought, what's going on here? And I think my own personal opinion is that the petroleum companies are cheaping out as much as possible. They're dumping as much as 25-30% aromatics into your gasoline now. And people are blaming ethanol, which I don't think is at all to blame for this stuff. So you have rubber products that are just falling apart in fuel delivery systems, and they're blaming the alcohol when in fact it's these aromatics. They're called BTEX. It's a short version for a number of different chemicals like xylene, toluene, ethylbenzene, and benzene. That's BETX. So I talked to Holley and I said, these O-rings are failing. And they said, yeah, we're going to come out with a Viton O-ring to replace that, but it's not ready yet. So I'm like, come on, finish this product so I can talk about it, because it's a very simple solution to a very common problem. To answer your question, I'm comfortable with both of them. Some of the systems electronics oftentimes will be more difficult to diagnose. But the key again is you just have to look at it from the standpoint of looking at the simple stuff first. Does it have gas in the car? is there gas in the tank? Does your pump work? Do we have pressure? Do we have spark? Let's start there, right? And then we'll go from there.
You brought up a really interesting point, going back to the original theme of this talk about what has changed in the past 55 years for the average home mechanic working on their car. Certainly the chemistry behind gasoline has fundamentally changed, which made my mind immediately leap to all the changes in formulations for motor oil. Can you talk a bit about that?
Yes, the big change. We're still dealing with the fallout from that. In I forget what year it was. It's close to 20 years ago now. The American Petroleum Industry, API, they just about cut the zinc and phosphorus levels in half. And because that stuff, when the oil get into the combustion chamber and you combust it, those byproducts would then travel down the exhaust and poison the catalytic converter. So they dropped the zinc and phosphorus levels. People call it ZDDP, zinc dithialphosphate. Dialkyl phosphate. I have to look it up every time I have to spell that word out. It's ridiculously long. It's ZDDP is the common abbreviation for it. That has spawned a whole industry of boutique oils now for hot rod oils that don't carry the API donut sticker on the oil can to solve that problem, because we went through a rash of people just killing camshafts, left and flat tapping camshafts. And people were, again, blaming the lifter manufacturers, blaming the camshaft manufacturers, when in fact, they had changed the formulation. Same thing happened to me in California in the, I forget what year this was, but it was probably the early 90s. They reformulated the gasoline and didn't tell anybody. And I was playing around with a Quadrajet carburetor on my daily driver El Camino, and I had this thing leaned out within an inch of its life. You could tell what the temperature was outside by the way the car drove, because the cooler it was, the worse it ran at part throttle, especially when it was cold. Once it warmed up, then it was fine. But one day, it just fell on its face. It wouldn't even run. I had to readjust all the circuitry again and open it up like 15%. I thought, what happened? Then one day I'm pumping gas. I noticed this sticker on the pump that said, "Oh, we're now selling reformulated gasoline." So I called a chemical engineer friend of mine, gasoline engineer. And he goes, "Oh yeah, they're putting ethanol on their aromatics at that time." Later became ethanol, and it leans it out by about 10%. I thought, okay, that's what happened. Yeah, so there's things going on that you assume would not be, that would not change. Gasoline is gasoline. No, it's not. It's changed radically and is continuing to change. And then there's the whole issue with ethanol and stuff like that. But that would be a whole another hour-long conversation.
Well, Jeff, I guess that just means we're calling you back in a couple of months. So clear your schedule for us. Looking back, though, we've been talking about specific advancements, specific changes. Can you talk a bit more in general strokes about the performance industry, the performance aftermarket? How has that changed since you first got into this?
Yeah, well, it's become far more sophisticated, which is a good thing, and along with that, the enthusiasts have become more sophisticated, and so they ask more difficult questions, which is kind of where I see it, and with that, sophistication has become more challenging. I mean, from an OE standpoint, I can't imagine trying to be a diagnostician for General Motors, let's say, for new trucks that are hybrids, right? They're part electric and part internal combustion engines. It's like, oh my God, you have to have a working knowledge of both of those, an intrinsic knowledge of both of those. It's extremely difficult. I wouldn't even know where to start, with something like that. I mean, I suppose with enough time and experience and making enough mistakes, you'd probably get pretty good at it. But so the diagnostic part of it probably is the biggest challenge. And then with the sophistication in the aftermarket, that requirement for you to be more sophisticated with what you're doing has risen dramatically. I just had a long discussion yesterday with a buddy of mine who's thinking about buying a GM 10-speed automatic transmission, to put behind in his Chevelle. And I'm actually counseling him. I said, I did a quick blast through the internet just looking for information. There's not a lot out there on that. If you want to bolt it behind an existing Gen 5 engine, well, then all the GM's done all the packaging and all the tuning and everything for you. But if you want to put this essentially a hot rod mix and match kind of deal, which is what the aftermarket really is all about, right? You're now a pioneer. So I'm trying to counsel my friend that, I don't know, man, could we make it work? Yes. Is it going to be painful and perhaps very costly? Yes. So, as long as you're okay with that, then we'll learn something from all of this, but it's likely to be A, painful, and B, expensive. So that's the hard part with the technology. But the other side of it too, I can remember thinking, man, I don't know, do I want to get involved with LS engines? Do I want to dive into that whole mess? Because it's a whole different engine, and I don't know. And now look at it and say, no, they're not that bad. They're a lot of fun, and they're great engines.
Yeah, but then looking back, again, to a hot rodder in the late 60s or the 70s, 80s, adapting something that wasn't originally intended to do a certain job, it typically meant like a physical, mechanical solution, like finding adapters, finding brackets.
Or making a bracket, and so you have to learn how to be a fabricator. And when in reality, that was the beginning of hot rodding. In the beginning, there were no kits. These guys, I mean, think about how sharp those guys were. A couple friends of mine are working on a project alongside with Iskandarian, and they're going to modernize and recreate Iski's original Roadster, his 29 Model A. And they're not going to put a flathead in it, but they're going to do something else. And they were I just watched their video. It's Alex Taylor, along with the guys from Iski, and of course her dad, Dennis Taylor. And they were talking, and Dennis was talking about all the stuff that Iski did to that car. He had to make everything because there were no kits back then. This was in the 40s. This is before World War I or World War II rather. So just crazy stuff. Then you had to fabricate and you had to make things. It really hasn't changed that much. It's just much easier now to do the conventional things because the manufacturers have made it easy by you just buy the kit. It's great. You don't have to know how to weld. But eventually, if you get into it deep enough, you do need to learn how to weld and you do need to learn how to fabricate.
Okay, so this may be a tough question to answer with any specific date, of course, but when did the automotive aftermarket start coming through with like comprehensive kits? Say, if you wanted to install a turbocharger in a non-stock application or a supercharger, or if you wanted to do an LS swap, you can go to summitracing.com right now and find LS swap kits for, say you wanted to stuff an LS into a first-gen Camaro or a Tri-5 Chevy or even a Fox Body Mustang. You can find companies out there that will show you exactly what steps and what parts you'll need to make that happen. Is that a relatively new phenomenon, or has that been around for a while?
I don't know why this just popped into my head, but Axle actually built a turbocharger kit for a small block Chevy back in the late, I think it was 1979 or 1980, because I can remember seeing that and wanting to do a story with it. We never did at Carcraft, but it was a bolt-on turbocharger kit, and it was to blow through a carburetor, which really, there's a lot of issues with that. Can you do it? Yes. Do you need to know an awful lot about carburetor circuitry in order to blow through a carburetor? Yes. Is it consistent? No. Can you make the idle circuit work really well? No. Not without a tremendous amount of knowledge. Because I've tried it. I gave up on a blow-through centrifugal supercharger on a carburetor because I couldn't make the idle circuit work. I couldn't keep it lean enough. And then I talked to a couple carburetor, guys, and they went, that's a walk in the park. What's wrong with you? It's like, well, you know something I don't. So, and then tried to pry that information out of them, and they wouldn't give it to me. So it's like, okay, that's fair. You spent days, weeks, months determining that. I understand, so that, and that's to be expected. So yeah, kits really probably started in the mid 80s. You buy all these parts and then bolt it on. And all that does is bring the level of sophistication down enough so that your average enthusiast, your entry level guy, could pull that off and make it work. And that's the beauty of it. That's really, because the hard part with diving into a project you've never done before is you don't know what you don't know. So you don't know you don't even know what questions to ask, because you don't know that there's a landmine out there just waiting for you to blow your foot off if you're not careful, and, or blow your engine up, or, do something nasty, or just cause headaches. And yet someone else will go, oh, it's this solution right here. It's very simple. Just do this. And the solutions are always simple once you know what the answer is. It's finding the Suzuki Dakota ring that will give you that answer. Sometimes those are hard to dig up. So.
Okay, so far during this interview, we've been taking a look back at like the last, say, 55 years of automotive performance evolution for the home gearhead. You want to break out your crystal ball and put on your consultant hat? Let's say you have the heads of all the major aftermarket performance companies and the OEMs all in one room. Can you point to where you think the performance industry needs to go?
Well, the performance industry has always followed what the OEs are doing. So, and of course, I could hear people cringing right now. Oh, electric cars! Oh my God! I don't have a problem with electric cars, but from an internal, I think it's a mistake to try and think that we are going to go completely electric. That's just ludicrous for a lot of different reasons. But I think that from the future of it, it's going to all come back to control again. Digitizing control over systems. There are a couple of companies, I think off the top of my head, Viking, for example, has what they call, I think, their Berserker system, which is an electronic control of their shock absorbers to essentially give you an aftermarket electronic control over your suspension, active control over your suspension. That's just crazy. I've talked to Chris King about that, the owner at Viking, and it's ridiculously sophisticated and very complex, and you really have to know what you're doing in order to make something like that work. But is that another point in that favor? Yes, I think it is, and it will eventually happen over a period of time. When you design something, I'm not a designer. When I was in grade school, I wanted to be an engineer. And then I discovered that math and I just did not get along because I was more of a creative person from a writing standpoint. So gave up on that idea. But I have learned that it's easy to make something complex. It's far more difficult to design something that's simple. But when you see a simple idea, then you just think, oh, why did it take us 50 years to get there? But you see sophistication like there is an aftermarket system, I don't know the name of the company, that has a kit where you can do, you don't have to mechanically depress the clutch to change the gear, make a gear change in a mechanical transmission. So it will do it electronically for you. And all you do is essentially, there's a strain gauge on the shifter. And as soon as you pull on the shifter, it instigates electronic control over the clutch mechanism, hydraulic clutch, disengage the clutch, pull the gear change, and then re-engage the clutch. And it's much, much faster than you can do it by hand. So mechanically, so stuff like that. It's complex and ridiculously expensive, but that's the idea behind the OE dual clutch applications. Now, essentially Clutchtronic kind of stuff. That I think will trickle down into the aftermarket eventually at some point, and hopefully become affordable. Where you could have something where you could be able to bang gears on in your 66 Chevelle, without. I mean, there's still going to be a clutch pedal there, but you don't have to touch it because it's being electronically controlled.
And I would assume products like that would follow a similar trajectory to pretty much any technology, where it becomes more affordable and more accessible as the technology matures.
Yeah, and it will eventually trickle down. It always does. I can remember when we first started working on the LS engines, and I did all the truck engine stuff because they were cheaper to buy because they were iron block engines. An LS1 was, oh my goodness, it was ridiculously crazy. Now it's like, don't even want one. Now it's like, rather have a 6.2, an LS3, much bigger, makes more power.
Earlier in our talk here, you brought up briefly the electric elephant in the room. How do you think that relationship's going to play out? Do you believe there's room for both the electric and the internal combustion engine gearheads to coexist peacefully?
Yeah, I think so. I was actually, when all this stuff first came to a forefront, I don't know, maybe 7 or 8 or 9, 10 years ago, I actually played around with the idea of building an electric S10 as a drag race car. And I was so uneducated in that whole process that I thought I could do it with a bunch of DC batteries, right? Just a bunch of car batteries in the trunk of the bed of the truck. It was like, no, that's not how that works. and also the fact that, and a lot of gearheads don't understand this, that all your performance vehicles, all your electric vehicles are all AC electric motors, but you're running DC power supply. And so you've got to convert it. You've got to do it through an inverter, and you lose efficiency when you do that. But that's what you have to do in order to make it work. But are they quick? Oh, ridiculously quick. I don't know what the electric car, like sedan current record is, but I think it's in the sixes. So they're very, very quick. From a performance standpoint, they're a lot of fun. They're very, very quick because you have instantaneous torque. That's the thing. But as one friend said to me, he said, yeah, but they have no soul because there's no visceral attachment to it unless you're driving it. But to watch it, it's just like this whoosh, right? Goes down the track. There's no noise. There's no activity. Like for anyone that's listening to this who's never been to an NHRA drag race and never heard a top fuel car or a funny car, oh, you got to do it. It will blow you away. It will thump your chest, and it's an amazing experience. That's the visceral part that you don't get with an electric car. So that's the downside to it. But they have their place. My perspective has changed a little bit from electric cars now that I live in a very rural part of Iowa. Out here, it makes no sense to have an electric vehicle, really. And certainly not for any sort of towing or pulling, because the range is ridiculously limited. It has great towing capacity because electric vehicle does, because it has instantaneous torque, but energy density is the key. Gasoline versus electric power. So that's the downside to it. But I think there's a peaceful coexistence. Sure. Yeah. I do know from doing it. I did a story for Hot Rod a couple of years ago on the electric car performance concept, and built the story around that Camaro that an outside firm built for Chevrolet that was kind of a technology demonstrator. And the car ran in the 9s, I think, and it was essentially built really to exemplify or show what you could do if NHRA were to do a stock eliminator electric car class, where the power level was essentially similar to probably a hopped up LS motor. And the car ran in the 9s, and it was very quick. And what they learned was, at first, didn't use a torque converter, and then later actually put a torque converter in it. And the more you built the car as if it were internal combustion engine powered, the quicker it was and the easier it was to manage.
Well, Jeff, I think we've pretty much covered the gamut. We look back 55 years, starting around the late 1960s, and here we are talking about electric drag racers. But before we wrap up, I want to ask about you. What are your plans? You got any crazy projects lined up?
I've been kicking this idea around for many years, and in the beginning, it wasn't practical, and now I have no excuses. I need to just do it. We had touched on E85 earlier and ethanol as a fuel. And of course, now living in Iowa, that's a big deal. more so for me than a lot of other people, but I see ethanol as a fantastic renewable fuel. It's an extremely high octane fuel. And the big knock on it is always that, well, you don't get the fuel mileage out of it. So I want to build, I've built this thing in my head several different ways, but like a 13 to 14 to 1 compression ratio, either small block Chevy or LS, probably an LS motor. I'm thinking I might make it carbureted, but it could do electronic fuel injection too, to take advantage of the octane of the fuel. So, and the reality is that I've learned quite a bit through research that, let's back up a little bit. When you mix gasoline, we'll just make this simple. If I've got 5 gallons of 90 octane gasoline and I've got 5 gallons of 100 octane gasoline, I mix the two together, I have 10 gallons of 95 octane fuel. That's not what happens with ethanol. With ethanol, you get extremely high returns for very low percentages of mixture. So when the EPA dictated E10, one of the advantages, well, it turned out to be not an advantage for the end user, but it was somewhat of an advantage for the petroleum industry. A 10% addition of ethanol pulls up the octane rating by 3 full numbers. So what the petroleum industry did was instantly said, well, now we can build a lower octane gasoline, mix 10% ethanol with it, and give you 87. And they just made a cheaper fuel. But if you take that from a performance standpoint, if you start mixing ethanol with gasoline, if you mix it like E50, so 50% 91 octane gasoline with 50% E85 or even pure ethanol, it doesn't matter. It's not that big of a difference. You can come up with about a 96 or 97 octane gasoline. And that alone might run a 12.5 to 1 compression ratio motor, and now I can have ridiculously more power and more efficiency and drive it with essentially quote unquote pump gas. I have to mix my own. That's the biggest hassle. So that's one of the ideas I've been kicking around. I've got a bunch of projects, mostly engine build stuff. I want to build like a L70 or an LT1 replica engine, small block, but make it high tech on the inside. So I'm actually working on designing it on paper right now, just going through all the parts and stuff. And that there's a drag race program. It's not out here in the Midwest, but on the East Coast and in the upper Midwest, it's a big deal called FAST, factory appearing stock tire class. Have you heard about that stuff? It's very cool. So you have a stock looking muscle car, and you can do anything you want as long as the block, the cylinder heads, the intake manifold, the carburetor, the transmission all look like they are factory stock. So you have to run their casting numbers, right? But internally, you can do whatever you want with it. So you can take a 396 and turn it into a 572, or a 598 small block or big block, and make ridiculous power with it. But it has to look stock on the outside with cast iron manifolds. These guys are running in the 9s with stock tires. They have to run a stock tire, whatever came. So if you've got a 69 big block Chevelle, you might build a 572 for it internally, but you still got to run it through stock F70 tires. Yeah, it's crazy. That's something I would love to get involved with. I think that looks like a lot of fun. But unfortunately, it doesn't happen around here. I have to go to Michigan to race. So it's a long way to tow. But it sounds like a lot of fun. So stuff like that is what intrigues me. There's always new stuff coming. That's the biggest part. That's the most fun of this whole thing is it never gets stagnant. The industry is constantly changing.
Well, that seems like a fantastic sentiment to end on. With that, Jeff, is there anything else you want to tell us about?
No, other than put a plug in for my Car Guy Confessions with Jeff Smith podcast that we do, video podcast I do with my friends Steve Strope and Ken Benty. So if you want to check that out, we do usually one about every 2 weeks. We do interviews, kind of like this. We do a video stuff too, and sit around and talk about cars. It's a lot of fun. And
that is a great name, Car Guy Confessions with Jeff Smith. Where can we find it?
It's on YouTube. So if you just search Car Guy Confessions with Jeff Smith, it'll pop right up.
Well, with that, Jeff, thank you so much for taking time out of your day to talk about the evolution of the gearhead hobby with us, at least the evolution of it over the last 55 years. Thanks again for the talk, and good luck on those upcoming projects.
Sure enough. Thanks for inviting me. This was a lot of fun.
This has been the On All Cylinders podcast.
Powered by Summit Racing.
Check out new episodes coming soon at OnAllCylinders.com.
OnAllCylinders.com.
Thanks for listening.
See you next time.